All right, students, today is going to be the first lab that you're going to do in the class. To begin with, there are some safety guideline rules that everyone has to follow. There is no ifs, ands, or buts. There are no exceptions. Either you follow them or you will not be able to do the labs. Labs are privileges, not rights. So to make sure that everybody is safe and secure, that we don't have any mishaps, these are the guidelines that you must follow. First off, anybody with long hair, it needs to be tied back. If you don't bring in like a little hair tie or a scrunchie, something like that, I have rubber bands for you, but from everything I've been told, the rubber bands don't feel too good. So if you bring those in, what I would recommend you doing is keeping those hair ties with your safety glasses. Now, this is the other thing that everybody has to have to do the labs. All right, your safety goggles, I'm going to hand those out to you, and keep the bag. All right, don't just throw this away, because oftentimes if you have your goggles and you just throw them into the locker, they're going to end up getting scratched up, and that's not good. All right, you're going to be using these for the rest of the semester, for next year, so make sure that you take good care of these. All right, now the safety glasses, when you're finished, we can just put them right back into the bag, and then it avoids scratching up the lenses. If you have your hair tie, you can put that in here. In addition to the hair ties and the safety glasses, you shouldn't wear jewelry. Okay, now the lab that we're going to do for the calorimeter, it's not as big of an issue, but you don't want to be wearing jewelry and then get some chemical on it, and it might tarnish your rings or your watches. So jewelry, just put them into your pocket. All right. Baggy clothing, it's not acceptable. All right. So if you have on a sweatshirt something like this, nothing's hanging, we don't have anything draping down where it could catch on fire, great. If you have a zip up, then it needs to be zipped up to where it's not going to fall open on you. The hoodies, the strings hanging down, they got to be tucked into the shirt. Nothing can run the risk of falling either into a fire or onto some chemicals that you would then later come in contact with. So clothing is a key thing for you. In terms of clothing, it's not an issue right now at this time of year. I don't see anybody really wearing open-toed shoes, but when the weather gets nicer, if you're wearing open-toed shoes, that's not okay, because the risk of something falling off of the table, breaking, and then coming in contact with your foot, I have had it happen. All right. Students of mine in the past, I had one young lady, we were heating up, I can't remember what it was, we were heating something up, it was some glassware. We were bending some tubes, and the glass shattered, it fell down, and she had on a sneaker, but she had a skirt on, and it landed at her ankle, and it burnt her ankle. So you got to make sure that you wear closed-toed shoes, something that it's going to be as protective as possible, so that way we don't have anything coming in contact with your legs or your forearms or your face. So we got to make sure that you are protected. That's the key. If at any time during the lab these goggles come off, hair ties come out, loose clothing, the zipper comes down a little bit, you're losing points on the lab. Okay, you guys are sophomores. You should be mature enough that you understand the hazards that can come with a chemistry lab, and you will, follow the rules is what you're going to do. Okay, so in today's lab, first off, we have our goggles on. Okay, we are going to light the Bunsen burners. So here we have one of our lab burners. Now I'll point this out. On the bottom of it, we have what would be our secondary valve here. This would be like a fine tuning of the gas. On the desk itself, we have our gas jet, and then we have our main valve right here. The rubber hose, when you put this on to the gas jet, you don't have to force the thing all the way up on there. You just need to snug it up, okay? So that's snug on here. You will be on this side of the desk when you go to light the Bunsen burners. Okay, I do not want to see anybody on that side of the desk. The reasoning why I do not want you on that side of the desk when you're doing this is because if the burner is here and you're standing on that point, you're reaching over top of the flame to shut off the valve. Yes, you could move it over a little bit, but again, and I have had this happen, if the gas jet happens to malfunction, I have had gas coming out the bottom of the burner and flames were everywhere. That means that the person's having to reach over top of the fire. Whereas if you're on this side of the desk, the burner is here, I'm not near the flame when I have to shut off the valve. All right, when you go to light the burner, you're gonna have the torch in one hand and the other hand on the valve. I do not want to see somebody turning on the gas and then fidgeting around to light the torch. That is not the safe way to do this, okay? You will put gas into the room. We don't have to worry about an explosion. What we do have to worry about is that gas causing me and everyone else to get some headaches, and then I become grumpy. That's probably our biggest concern with that. All right, so it's not good for the gas to get into the room. We don't want that to happen, but we want to make sure that we do this correctly. So we're on this side of the room, or this side of the desk. I light my torch, okay? There's a flame right here. And then after this is lit, I'm gonna grab the actual gas jet. I'm gonna turn on the valve. Now, notice where I'm holding this. The flame, my hand is underneath the barrel of my burner. Okay, so the flame is coming out over top of the edge. It would not be a good thing to light the burner like this because then the flames come over your hand. But if my hand is beneath the barrel of the burner, I am not going to get burnt ever. Okay, so it's underneath the burner. I'm going to turn this on slowly, and it's as easy as that. Now, these burners are very easy to manipulate. You turn it on, it lights. There's no fine tuning that has to go on past this. But I will point out on the bottom, if we turn our valve clockwise, that will choke off a little bit of our oxygen supply. If I close off the sides, you can, this is a nice burner. I don't think I'm going to be able to get this. But if we choke off all of the oxygen, you can see that I have a very poor flame. It's not a very efficient flame. We need to get some oxygen mixing with that gas. So now we have a nice flame, okay? So that's one part of the lab. Second part, you need a beaker of water. All right, it doesn't have to be a lot. I have 200 milliliters, approximately 200 milliliters here. You never want to use a beaker for an exact volume. The beakers, this one happens to be graduated for every 100 milliliters. So this is in between 200 and 300. You have no idea the exact quantity of water in here, right? So we never ever use a beaker for exact quantities. What we're going to use is a graduated cylinder, right? So in this desk drawer, there were two graduated cylinders. There was a 50 and then there was a 25, right? In this lab, you're going to have to obtain 50 milliliters of water. If all you have is a 25 milliliter graduated cylinder, do not say that you can't get 50 milliliters. All you would do is you'd fill this up twice, okay? So you could fill the 25 up twice, or you could use the 50 milliliter and fill it up. Now, why do we use the graduated cylinders? Because it's graduated for every single 1 milliliter, right? I will get a more precise measurement of our volume of liquid using this than I ever would using the beaker, all right? So we have my beaker of water. Why do I want the water? Because I don't want a lot of people congregating at the sink or the back sink, turning on the spigot and filling it up, and then it goes past 50, they dump it out, and then they pour some more in. while everyone else is waiting on them. No, your stock water is going to be in the beaker, and then we're going to pour that into our graduated cylinder. So for this lab, it says in the directions here, it says that we need 50 milliliters of water. Okay, so 50 milliliters of water is what we're going to need. Okay, so I'll start by pouring in my water where I get close to 50 milliliters. I'm going to stop before I get to 50. I'm going to place this on the tabletop. Why? Because I do not want to look at it like this. And I don't want to look at it like that, because then I'm going to get a parallax. We're going to not get the appropriate amount of liquid by looking at it like this. We don't hold that. We want to have that on a level surface. Instead of filling this up and trying to get exactly at 50, instead, let's use our tools. We have an eyedropper in here. I fill up my eyedropper, I get at eye level with the graduated cylinder, and then I'm going to add water until the bottom of the meniscus, that's that curved line, bottom of that meniscus gets right at the 50 milliliters. Okay, now I have exactly 50 milliliters in my graduated cylinder. I've got my ring stand and my makeshift soda can calorimeter. What we're going to do is we're going to pour this 50 milliliters into my soda can here. We'll pour this in. Now, from this point, what we need to do is get the temperature of our water. And you can see in the lab directions, it says that we need to get the initial temperature of our water. Okay, so we'll get the thermometers out of the bottom desk drawer. Some of those thermometers, hopefully that wasn't loud. Some of those thermometers will be in a little plastic sleeve. If you see that, put it back in there when we're done. But what we'll do is we'll get the temperature of that water, and then we're going to record it on the data table. Okay? That is before we do any heating or any burning of our food items at all. Now, one person in the lab can be doing that. The other person in the lab, you want to grab yourself a cork. And you want to grab yourself a paper clip. Now, you manipulate the paper clip until, it's probably not, you probably can't see this, but it's just a little wire like this, so that way I can stick my food items onto it. Before you put your food items onto that stick, okay, before you do this, before you put it on here, what you have to do is you have to grab one of our triple beams here. Grab a triple beam out of the cupboard. You get the mass of our cheesy poof right here. You get the mass of the cheese puff, and we'll write that down in terms of grams. Now, your triple beam can measure to 3 places past the decimal. I want your values for your mass 3 places past the decimal when you're recording this. All right, so I have my mass of my cheese puff. I have the temperature of my water to start with. Now what we're going to do is we're going to stick that cheese puff right onto the paper clip, right like that. Now, in the lab, what we're trying to do is we're trying to figure out how many calories of energy does this little cheese poof actually have in it. All right, so in order to determine how much energy that this cheese puff has in it, we need to ignite it. Now, when we ignite it, that's going to start breaking chemical bonds. We're going to have heat energy that's being released. And what we would like to do is we'd like to capture as much of that heat energy as possible by the water inside of our can. Okay, so we're going to have our can set up, and you can see that it's very close to the actual cheese puff like this. You don't want this to where it's sitting right on top of it, because then you're going to muffle out the flames. We want it just about like this. Now, if yours isn't set up like that, what you can do is adjust the ring stand up or down accordingly. Once that's all set up, we want to ignite the cheese puff. Now, what you don't want to do, what you don't want to do is leave the cheese puff into the flame for an exorbitant amount of time, because then if you have this right here burning in the flame, you're losing some of that energy, aren't you? We're trying to capture as much of energy as possible right here in the can. So we only want to ignite it and then set it underneath there. So we'll do that right now. We'll ignite the cheese puff, and it shouldn't take too much effort to get this thing lit. And notice where I'm holding this. I'm not holding this on the wire. I'm holding it by the cork. So we'll let this burn. Now while that's burning, we are breaking the chemical bonds inside that cheese puff. We're getting an exothermic reaction. Energy is being released, and we're capturing that energy by the can. That can is warming up, the water is warming up, the water temperature is going to change. When this is all finished, I want to get what the final temperature is of the water. So my cheese puff is going to continue to burn. When it's finished, I'm going to write down the temperature of my water after the cheese puff has been completely exhausted. Okay? It's all done. Now I'm going to let that go for just a little bit longer, because just because there's no flame doesn't mean there's no heat being given off from that, right? When this is finished, and I have my temperature of my water, the cheese puff, we're going to put that into a beaker I have in the front of the room. Do not put hot materials into the trash can where there's paper towels. It's a bad combination, all right? So this cheese puff, we'll put that into a beaker in the front of the room when we're all finished with it. And we have the initial mass of the cheese puff. We have the initial temperature of the water. We have the final temperature of the water. And, all right, I left this off. We need to get the final temperature of my cheese puff, right? Or not my final temperature, the final mass of my cheese puff. I almost forgot that. So right here, you can see it says final mass of the sample. Okay, so what we can do is, once this thing is cooled off a little bit, we'll put this right onto my pan. We'll get the measurement for the mass of the burnt cheese puff. The value, 3 places past the decimal for it. Now once that's finished, you're going to go on to the next food item. We're ready to move on to the marshmallow. You follow the same procedure. And then the last one, we're going to have a cracker. Now the cracker, we can't put it onto the paper clip. So instead what we're going to do is we're going to use a pair of tongs. So the pair of tongs, you put the cracker into the tongs, you light it, and then you hold it underneath. So same idea, just we don't need the cork for that part, okay? After everything is said and done, we want to make sure that we turn off our burner. We'll turn this off. And at no time should anybody leave their station unattended. No flame should be going when there's no one at the desk. We always have to have somebody at the desk if a flame is going. Everything needs to be broken down and wiped off before you guys take off. Once you're done with that, then you can move on to answering your analysis and calculation questions on the lab. After you're finished with all those calculations, you've made all of your, you've answered all of your questions on here, go ahead and submit that to Schoology and we'll be good to go. All right? So hopefully you enjoy the lab. We'll do more of these if I find that we have very conscientious young adults that know how to follow the rules and can read directions. Okay? Take care.